All right, here we go. We're going to be talking about solving equations or these quadratic equations that are not factorable for the most part with the quadratic formula. And that's the formula that's up above in the circled or I guess starred area. And when we're talking about these pieces of the equation, we are talking about when we have a quadratic equation in standard form, it's ax squared plus bx plus c. So a is going to be my first coefficient in front of the x squared. B is my coefficient in front of the x. And c is my constant. So that's the number that doesn't change. So we'll notice that in here we have a b a couple times, we got an a couple times, and we got a C at one point. So we need to make sure that we are cognizant of which letter goes with which coefficient. So now if we were to take a look at this first one, when it asks us to solve by the quadratic formula, the first thing I always do is label what my a, b, and c are. So there's nothing in front of the x squared, so I know my a is 1. I know my b is -7, and I know my c is 11. So from here, when I'm solving, I first would find the square root piece, and that's called the discriminant. So if I do the b squared minus 4ac part, that's the part that's under the discriminant, I would do -7 squared minus 4 times 1 times 11, and that would give me 49 minus 44, so that's 5. So now I have this section, that's the b squared minus 4ac, figured out. So then the rest of my equation when I'm solving is just going to be x equals opposite of b, so that's 7, because the opposite of -7 is +7. It's plus or minus. Instead of writing all that in there, we just got to do the square root of the number we just found, which is 5, and then over 2 times a, which is 2 times 1, which is just 2. And then at this point, we look to see if we can simplify it all. So under the square root, can it be simplified? Can we divide a number from the top and bottom? And in this case, I can't simplify the square root of 5 because there's no perfect squares that go into it evenly. And I can't divide the coefficients by the 2 because there's a 7 and a 1 up top. And I would only be able to divide by 2 if both of those numbers were divisible by 2, and neither one is. So we just leave it as this fraction. And now the reason why we use the quadratic formula is because we've been solving in different ways, solving by square roots, and we've solved by factoring. And in this case, we cannot do either one of those, so we're stuck. So this is the way that you would use if you couldn't factor, you couldn't solve by square roots, and it will work every single time. So we can actually solve some things that are factorable this way as well, and some things that would be able to be solved by solving by square roots as well this way. So solving by the quadratic formula can be your default for every single one if you really wanted to, and some people do like that, and they like just reverting to this every single time because it works. There's no questions about that in their head. So now if we were labeling my A, B, C for number 2, A is 6, oopsie, B is 1, and C is -2. So again, I would always do what's under the square root up above. So that's the b squared minus 4ac part. So it's 1 squared minus 4 times 6. Sorry, that's a bad 6. Times 6 times -2, 4ac. So that'd be 1 plus, in this case, because there's 2 minus signs I see a negative in front of the 4 and a negative in the 2. And that'd be 48, I believe, because 4 times 6 is 24, times 2 is 48, so I get 49. So now I'm going to do x equals opposite of b, that's -1 now, plus or minus the square root of 49, all over 2 times a, which is 2 times 6. So if I were to try to simplify any of this, I know that the square root of 49 turns into 7. I know that 2 times 6 is 12. So now I have this fraction without any radicals in it. So that means I can actually simplify this. One answer would be -1 plus 7 divided by 12, because that would take care of the plus sign. And the other answer that I have, because there's a plus and a minus there, would be -1 minus 7 divided by 12. So if I do the plus 7 divided by 12, I think that gives us 6 over 12. And if I do the minus 7, that gives us -8 over 12. And both of those fractions can be simplified. So in the end, I think I'd get 1/2, because we do 6 divided by 12 in my calculator, and do math and then frac. And then -8 over 12 would give me -2/3. So this would be my two answers there. So that is how we use the quadratic formula on a couple. So let's go on to 3 and 4. So A is 3, B is 14, and C is 8 in this case. I'm going to do the discriminant, it's called, the b squared minus 4ac part first. I'm going to see what we get. So if we do this correctly, that'd be 14 squared minus 4 times 3 times 8. Now I'm not sure. This one I feel like might give us something pretty strong. So let's do a calculator here. Let's use this. So 14 squared minus 4 times 3 times 8. Let's see what we get. Oh, 100. That's not bad at all. All right, so now we get 100. So I would set up the rest of my equation. So it's opposite of b, plus or minus the square root of 100 all over 2 times a, which is 2 times 3. So if we were trying to simplify this down, I know that I can actually simplify 100 to 10. So now I have plus or minus 10, and then 2 times 3 is 6. So again, I don't see a radical left over, so that means that I'm going to actually add and subtract that 10 in this case. So one of my equations would be -14 plus 10 divided by 6, and the other equation would be -14 minus 10 divided by 6. So I'm going to get two separate answers. So one answer, it looks like it's going to be -4 over 6, and the other answer is going to be -24 over 6. So now I think when we simplify that, that's -2/3, and then -4. So my final answer would be x equals -2/3, and x equals 4, or -4. And you'll usually have two solutions because we started with an x squared, so that usually tells you how many solutions you have, okay? Sometimes you might get only one if it's the same solution twice. That's okay too. For this next one, if I label what my a value is, my b value, and my c value, I got 1, -7, and 12. So if I were to set this up correctly, that's opposite of b, plus or minus, oh, I should just do my discriminant first. I'm sorry. I was jumping ahead there. I meant -7 squared minus 4 times a times c. That'd be 49 minus 48. I think that gives us 1. So now that would be x equals opposite of b plus or minus the square root of 1 all over 2 times 1. So again, this is nice because I know that I can simplify the square root of 1. That is on my list of perfect squares, and that turns into 1. So now I have x equals 7 plus 1 divided by 2, or x equals 7 minus 1 divided by 2. So I think I'm going to get two nice answers here. I'm going to get 8 over 2 or 6 over 2. And both of those answers can be simplified to 4 or 3. And I think if we factored that, that would be our two answers at the end, because I think multiple of 12 that adds to give me -7 would be -4 and -3. And then when you solve, you'd get +4 and +3 when you get x by itself. All right, so last two. That'll be it for today. My a value is 11. My b value is 14. My c value is 3. So if I did 14 squared minus 4 times a times c, that's what the setup would be. So let's punch that in because that's a bigger one. So we got 14 squared minus 4 times 11 times 3. So we get 64 for that one. So now we have x equals opposite of b plus or minus the square root of 64 all over 2 times a, which is 2 times 11. So now we have 64. I can actually simplify because it's on my list as well. So now we have negative 14 plus or minus 8 over 22. So again, I can simplify that by doing negative 14 plus 8 divided by 22. Or I can do negative 14 minus 8 divided by 22. So I think in the end, we get negative 6 divided by 22. And on this side, we get negative, what is it, 22 over 22? So my two answers are negative 1 for sure on the right side. And on the left side, I think we can only divide by 2. So that'd be negative 3 over 11. So my two answers are negative 3 over 11 or negative 1. So that must have been factorable as well. And then number 6, the last one that we got, if we label my A, B, and C, let me make sure that this is a 50. Yep, it is. So A is 2, B is 20, C is 50. I do my B squared minus 4 A, C. So let's see what we get here. 20 squared minus 4 times 2 times 50. We get 0. So that's an easy one. So it'll be x equals opposite of b. So it'll be negative 20 plus or minus the square root of 0 all over 2 times a. So I think this one, if I simplified it, that'd be plus or minus 0 because the square root of 0 is 0 all over 4. And I know that negative 20 plus or minus 0 doesn't do anything to my problem. So it's really just negative 20 divided by 4. So in the end, this is one where you only get one solution because it would be the same solution twice. It would be negative 20 plus 0 divided by 4, negative 20 minus 0 divided by 4. So you actually get x equals negative 5 twice, but you only need to write it one time. And that would be your answer for number 6. So that covers how to solve using the quadratic formula. I'll see everybody tomorrow for our next day of the dropped object formula.